All right, we got about a minute and 15 seconds remaining. Sure, I guess we can try it. Yeah, try it. Let's see how it turns out.
So like it's I don't really understand myself. I don't really understand.
All right. Greetings, scholars. So welcome, right? This is it, right? We meet today, and then Wednesday's our last live session. So welcome back, everybody. I'm glad to energetically see you all here. Obviously, we're not physically in front of each other, but I can feel your presence. I know you're here, right? Let me see. But yeah, hopefully everyone had a happy holidays. I'm not sure if any of you all would be willing to share any like interesting stories. Anybody have any interesting experiences or not? It's okay. You don't have to. Yeah, I was pretty chill, just relaxed. Attempted not really a truly vegan, but a vegan Thanksgiving. It turned out okay. I got a lot of research I need to do. I was like, I really wanted to try my hand at like a vegan mac and cheese. Needless to say, it did not turn out well. I was like, it got to a point because like I tried using a vegan cheese and that just did not work. I've made macaroni and cheese in the past and it was actually good. Like it was an old recipe using Velveeta and some other things, and that was good. That was just regular, right? But that was eons ago. Like people were still alive, kind of stuff. So I was like, well, let me see if I can mimic it vegan, and it did not work. Whatever cheese I used was like way too salty. I was like, yo, I can't eat this. So like in my mind, I'm thinking, I was like, okay, how can I repurpose this? Right? Like, how can I reuse this? So haven't done it yet. Right now it's all frozen. But like I was like, okay, I can like take it and dry it out, like spread it thin, dry it out, and then convert it into like a powder, right? And then use it as because it was so salty, I figured just use it as a seasoning for other stuff, so that way it doesn't go to waste. You can always repurpose and repackage stuff. Like that's just the way my mind works. So I was like, I'm tempted to try it and eager to see how it turns out because it can still be used because it's just vegan mac and cheese. Like it's just vegan cheese. That's the main thing. So then my analysis of the experience, I was like, okay, well, I want to see if there is a non-dairy Velveeta cheese because that was the one like the way my people would make it back in the day. That was like the bee's knees. But I've been on a quest to find/create a quality vegan cheese, and I have not found one. Like I've tried Daya, don't come at me, but I can't stand it. Like it's horrible. So I'm at a point where I want to try making my own and like seeing like, okay, can I get the taste and the texture? Can I create it myself? So anyway, that was my little bit of adventure. Let me see. So again, we only have 2 sessions remaining, right? 2 live sessions. So we'll do our best to maximize the experience. We'll go ahead and do another review today, and maybe on Wednesday, maybe we can do like a grade update because I do think we need to like process people's grades and just see where everybody's at and just kind of check in with people. I think that's a good idea. But I want to take some more time to review. So that's today. Wednesday again is the last official day live, and then Thursday and Friday of this week is going to be the reading period. So all classes should be canceled, and that's the time for you to like prepare for your finals. Our final should become available this Sunday morning at 11 a.m. and is due. The hard deadline for our assignments for the semester is a week from this Friday. So Friday, December 13th at 11:59 p.m. After that, everything locks out. All right. So idealistically, like in this time approaching this upcoming Sunday, you want to try to get caught up on your old assignments. Like try to finish everything. So that way, the only thing you'll be waiting on is the final. If you are, again, I know I said this before. It's going to be this Sunday. Yeah. I'll tell you. Yeah. So a friend of mine just reminded me, so the second Sunday of every month is free admission at the High Museum. So if you're in the city of Atlanta and you just want something free to do, if you have a little bit of time, I want to say it's from like noon to 4 on 17th Street, the intersection of 16th and Peachtree is the High Museum of Art. And I want to say right now they have an exhibit created by Alicia Keys and Swiss Beats, I think, where they did all this artwork. So I went like about a month ago, literally a month ago. I enjoyed it. It was really nice. But if you like art, art museums, they could be kind of weird and boring. Now, if you want to try, I don't know how PC this is. No. The final is going to be like the other exams. So it's going to be remote, right, on my math lab, right? So you'll have access to it for like 5 days. A random thing that I saw somebody do in a video, they were at an art museum and they put their shoe just like in the middle of the floor, and people like were like, oh, they're like treating it like it was actually art, And so that was trippy. Another thing that was trippy was some artist recently sold his artwork for $6 million. And you know what his artwork was? A banana duct taped to the wall. $6 million. And actually, before it sold for $6 million, it originally sold for like 120,000. So somebody bought that for 120,000 and then resold it for 6 million. And then when the person bought it for 6 million, they gave them, with their $6 million purchase, they got a roll of duct tape and another banana. I was like, what the fuck? Like, are you serious? Is this real life? So, anything is possible. Like, we're in the realm of possibilities. Like, whatever comes to your mind for real, like, where there's a will, there's a way, We've chosen this route of academia, right? It is what it is, but, it's not the only way, right? So I say that to say, do your best, forget the rest, don't stress, and be blessed. If in some off chance, if this realm just isn't working, best believe there's always another way. There's always another way, okay? So, I just thought those were interesting. Okay. So let me see. Yeah, if we are going back to do old assignments, I would encourage everybody to prioritize their exams first because that's where we're going to get the most bang for your buck. So, if you're going back, you're trying to boost your overall grade, prioritize your exams. Try to maximize those scores as best as possible. I think you can earn up to maybe 90% on the late assignments. I just did. I didn't get a chance to change it before you all accessed it, so I can't really change it now. So but as far as a late penalty. But yeah, once you get your exams in order, and then the thing I would encourage you to prioritize last is the homework, because the homework is going to be a lot of work for minimum points. Yeah. So then once you kind of complete all the assignments and preparation, again, the final exam, you can anticipate it to become available this upcoming Sunday morning at 11 a.m. You can access it for like basically the week for 5 days. And it's due this a week from this Friday, which is Friday the 13th, okay, at 11:59 p.m. So we're still reviewing this week. After that Friday the 13th, I'll probably wait until like Monday, and we have to calculate your final grades, all right? We have to push everything through, okay? I want to say also there is a course evaluation, so I want to say check your Morehouse email, so check that out, and I'll be sure to do that. Let me see. I think that's the meat and potatoes. Let me check the chat again real quick. I saw that one notification earlier. I think we are Gucci. Okay. So yeah. This is it. We're in the home stretch. Okay. All right. So let's take some time today to kind of continue the review. We've already done give me a random number, and it gave us question 42. So we'll start off with question 42. That should be charged. I'll let it go for a little bit longer. Let's minimize this. Okay. So this question comes from section 1.5. Let me see. I think that's like transformation of functions, right? Describe how the graph of the following function can be obtained from one of the basic graphs. So here, it looks like the basic graph is 1 over x. This is kind of trippy. I feel like I have to like talk about this like it's like current events, which is obviously not current events. And I know how drab and boring it could be, but it's fun to me. Because it's this whole story. It's this whole hidden narrative that a lot of people just aren't aware of with these different things. Every question has like a story behind it. So anyway, it's just a random thought that I had. But yeah, so the basic function here is the reciprocal function, 1 over x. So that should kind of create an image in your mind. The 1 over x, it has, generally speaking, with no manipulations, has a horizontal asymptote along with a vertical asymptote with the x and y axis. And I want to say generally, it kind of, it's almost like a web shape almost, where it starts, I want to say below the x-axis, on the left side, and it basically is in quadrants, 1 and 3, so you should get an image when you think reciprocal x, the reciprocal function. Okay, and so now we have this 4. So what that is, that's like multiplying the outside of our basic function by a number larger than 1, right? So when we were doing transformation of functions, we had basically 10 transformations altogether. And they were kind of broken into 2 main categories, whether it was a inside or outside manipulation. Yeah, that's it, really. Inside manipulation or outside manipulation. Generally speaking, inside manipulations cause horizontal changes and are generally the reverse of our intuition. Outside manipulations cause vertical changes, and they tend to go with our intuition, right? So if we were to multiply the outside of our basic function, which is 1 over x, if we multiply the outside by a positive 4, that's going to cause a vertical stretch by a factor of 4. It causes vertical change, and it gets bigger vertically, which follows our intuition, okay? So, I know that sometimes students struggle with making a distinction between an inside manipulation versus an outside manipulation. I would encourage you maybe start with the basic function. Like you could say f of x equals 1 over x. And then just kind of play around a bit. Like say you said 4 times f of x, right? So that means you're multiplying the outside of your basic function by 4. Do you get this? If you said f of 4x, where you multiply the inside by 4, does it give you this, right? Just try that out a little bit, see if that helps. So again, we said we had the reciprocal function. We cause a vertical stretch, right? Cause a vertical change. Okay, so we start with the graph of y equals 1 over x, which is here. I stretch it vertically by multiplying each y value by 4. Foul. I guess I gotta zoom out. I'll use that for now. Check. Okay, not too terribly bad. So that was more a review. Let me just kind of briefly recap the 10 transformations. So the first 4 are called rigid transformations, where you can move it either up or down by, if you add a positive on the outside, it moves it up. If you subtract a positive on the outside, it moves it down. If you add a positive on the inside, it moves it left. If you subtract a positive on the inside, it moves it right. If we multiply the outside by a negative, it flips it vertically. If we multiply the inside by a negative, it flips it horizontally. If we multiply the outside by a number larger than 1, it causes a vertical stretch. We multiply the outside by a number between 0 and 1, it causes a vertical compression. We multiply the inside by a number larger than 1, it causes a horizontal compression. And the inside by a number between 0 and 1 causes a horizontal stretch. I think those are the 10, right? So I know that's kind of a mouthful. If any of that feels foreign, you definitely might want to bone up back on section 1.5. If you just want to avoid 1.5 altogether, honestly, I think you'll be okay. You do miss out on a good amount, but you can get by without that stuff. But you'll be better equipped if you have it at your disposal. Okay, let's go ahead and move into another one. Generate. Could we do a problem about substitution? Okay, let me see if I can find one. So that's going to be kind of towards the end. Let's see. I'm just going to kind of work backwards. That is the right section. It says use any method. This is like a good one to solve for substitution. Okay, so we'll go ahead and do this one. How I found that on the first go, but I was like, okay. All right, so let me get a copy of these items, the pertinent information. Again, I typically like to include the question ID, so if you ever review these notes, you know where to find it, like where in the textbook it's coming from. Right. There. Ooh, too slow, okay. And I want to say last time we met on a week ago, I basically kept the notes for the whole day in one set of notes. Instead of posting multiple, I just did one long set of notes for the day. I low-key had this idea today. I was like, should I just stream all day? But if I was going to stream all day, I'd probably just do gaming and just be available, which is what I'd be doing anyway, and napping and stuff. Like if you guys want to work questions or whatever, we can. Use any method. Okay, so there was a request for substitution methods. So I'm going to grab this. Okay, so now we have this system of equations. Notice that the highest variable is the highest power in any variable is a 1. So this second equation looks like a good candidate to isolate a variable, right? So if we isolate y, solve for y. Let's go ahead and do that in a second. So we can subtract 3x from both sides. In that second equation, if we subtract 3x from both sides, we're going to finish with y equals, I'm going to write it as 13 minus 3x, all right? Because we subtracted 3x on both sides. So then what we want to do, and I think I'm going to go ahead and put this in blue just for a little bit of contrast. Okay. So then what we like to do is take this piece of information that we got from the second equation and substitute it into the first equation. So we're going to replace the y in the first equation with this blue y, this new y, this new blue y, right? Okay, anyway. So 7x minus 2y, I'm leaving a blank set of parentheses, equals 13, okay? And into the blank parentheses goes the isolation we just found. So 13 minus 3x. Again, all I did was replace y in the first equation with the y that we solved for in the second equation. Now, at this point, we have one equation, one unknown, so we can solve. We can distribute this -2, okay? So then we're going to have 7x. What is that? Is that 26? So minus 26 plus 6x equals 13. 12, 13x. We add 26. What is that? 39. 3. So x, divide both sides by 13. X equals 3. Okay, so if that's our x, we can use that to go back and solve for y. So earlier we said y equals 13 minus 3x, but our x is 3. So then y equals, what is that, a 4? 13 minus 9? So our claim is that the solution to the system is going to be the ordered pair 3, 4. Okay. So that was just a demo using the substitution method. Remember, we also had the graphical method. We could put both of these, type them directly into Desmos, see where they intersect. So let's do a quick check. So when x is 3 and y is 4, in either case, we should get 13. 21 minus 12 is 21 and 12. That's not right, is it? Oh, not 12. Sorry. 21 minus 8. So minus 7 is 13. Okay. 9 plus 4 is indeed 13, right? So this ordered pair works in both. Okay, so let's hop back here. We got the ordered pair 3, 4. Come on. Let me get rid of this. It's gonna be more. Okay. Oh man, you are like moving so slow today. But that's annoying. Okay, well. Okay. All right, I think we are Gucci. Okay. Let's generate. Let's do another random one. Generate. Let's go to question 102. Here now. Right there. So determine whether the following system is consistent or inconsistent. If the system is consistent, determine whether the equations are dependent or independent. Is one a multiple of the other? No, right? Okay, so right off the bat, I started to do elimination method here. But one way to quickly test whether it's dependent or not, if one equation is a multiple of the other, then we can say that the system is consistent and the equations are dependent, right? So if we multiply that first equation by 3, we get 18x minus 21y, but then we get a 33. So when the variables match and the solution matrix doesn't match, then that means that it's inconsistent. If it matched across the board, then we could say that they're dependent. But this is an example of something that's going to be inconsistent. So in other words, the variables would cancel out and we would finish with a false state, right? If we tried to solve the system. Okay. Let's generate. We'll go to question 22. Determine whether, this comes from section 1.3. This is just before library functions, I can tell you. Determine whether the equation defines y as a function of x. Okay. The vertical line test, we could look at the graph. This would pass the vertical line test. This is just the reciprocal function with like transformations, right? So like one way that we can go about solving this is look at the graph and then ask yourself, does it pass the vertical line test? And keep in mind that those vertical asymptotes, they don't go, only thing that's vertical is the asymptote itself. So that means that, you know, our function is always going to have a slight slant to it, even though it looks vertical. This would be a yes, right? Because the reciprocal function is a function of x. Y is a function of x. All right. Let's see. I just want to see real quick. Let me go ahead and say yes here. And I just want to see the way the book does it. I'm going to say view an example. So, yeah. Yes, already solved. Yeah, okay. Okay, so the explanation that they gave, they said to determine whether an equation y depends on x is a function, it's often easiest to solve the equation for y. If any value x in the domain corresponds to more than one y, the equation does not define the function. Otherwise, it does define the function, right? So usually the way it'll appear, if it's not a function, you're going to have like a plus or minus a lot of times. All right, so you'll find yourself doing some kind of even root. You have to introduce plus or minus. when you solve y in terms of x, especially if you have that plus or minus, that's usually the telltale sign. Usually, I can't think of another case. I'm not saying that there aren't other cases, but the usual telltale sign is if you get a plus or minus. Okay. Again, you can look at the graph and see if it passes the vertical line test. Let's go to question 82. This is good stuff. Like, it's a lot. Obviously, we can't get to everything, so we'll just try to get to as much as we can. Synthetic division. Let's go ahead and do this one. I feel like we should showcase polynomial long division, but I'm just going to do synthetic division. Unless somebody wants to see the polynomial long division, I'll do it. If you feel okay with it, if everybody feels comfortable, then I'll just do the synthetic. Okay, so suppose we wanted to do synthetic here. We can actually use the remainder theorem, right? Well, no, never mind. I was going to use the remainder theorem, but that's giving me something else. So let me just go ahead and do my synthetic division and stop being lazy. I was trying to think of a quicker way, and I'm sure there's some other way to use like the calculator to do this, but I'm just going to do synthetic division. Okay. Let's go like that. Click. Good. Nice. Okay. All right. So the first thing is that we have to be dividing by a linear binomial. We are dividing by a linear binomial, so we're in the clear. Again, the divisor, the denominator has to be linear and binomial, right? X minus 3. So then we take the potential 0 there, would be 3, and that's what goes in our chair. Okay, so we put 3 in the chair. Then we need to see, do we need any placeholders, right? Notice that the dividend, which is our numerator, is power of 3, is a degree 3 polynomial. So that means we need four coefficients. It doesn't look like we need any placeholder. It looks like every power is accounted for. So now we just take the coefficients, right? The coefficients are going to be a 1, 9, -7, and 8. Okay. And again, just the first number just comes down. On a diagonal, we multiply. Vertically, we add. So 3 times 1 is 3. Then that's a 12. What is that? 36. 29. 90 minus 3. Is that 87? 60 plus 27 is 87. 87, 97, 95. We got our negatives, yeah. Looks like the remainder is 95. So we started with a degree 3 polynomial. So then at this point, we have a degree 2. Do they want it in fully factored form? Can we go further? No. We can use a quadratic formula. Right now that we got it down to a quadratic, we could use a quadratic formula. But I don't think they necessarily want us to go further. They just ask us to do synthetic division. Let's go like this. So we got x squared plus 12x plus 29, and the remainder was 95. Nice. I think we're good. Let me get rid of this, and let's generate. This is where I could use another device. So to the side, do this part off to the side, but it's okay. I'm doing all this whole operation on an iPad. So I had other devices, they broke down, and I just was lazy about getting them repaired. I kind of want to get myself a Apple Vision Pro. I don't know. I have a lot of ideas. Let me mute this. Anyway, that's for another time. Okay. So this question comes from section 1.2, question 63. It costs $11, an $11 flat fee to rent a chainsaw plus $5 a day starting with the first day. Let X represent the number of days, and so Y represents the charge. The user write an equation in the form of Y equals MX plus B. Okay, that's not too bad. So the flat fee is $11 plus $5 times each day. That should be it. The first day you're going to pay $16, right? It's a flat fee plus the $5 for the first day. 2 days would be 10 plus 11, so on and so on and so on. Check, yeah, okay. I feel like that one wasn't too tough of bad. Let's generate. Let's go to question 103. All right, so I think 10, 9, 8, 7, 6, 5, 4, 3. Okay, let's finish this one. What else? The order pair associated with the value of the x value of 0. So when x is 0, that's like the flat fee. $11. When x is 0, order pair. 0, comma 11. All right. What do we say? 103, I think it was. Six, 5, 4, 3. All right, this comes from section 6.4, question 35. Solves the system of equation by substitution. Okay, since we've already done the substitution, I'll do this one by elimination, just to showcase elimination. We could do substitution, and that probably would be easier here to do substitution. But I just want to showcase elimination. Come on. There you go. Oh, no. Try that again. Okay. Movie references. All right. So elimination method, right? So we've seen substitution. Let me start by getting a copy. So we have this 3x minus y equal, let me write this a little bit better, equals 8. And then 6x minus 2y equals 10. Is this another one of those? So now, with the elimination method, the goal is to get one of your variables to have the same coefficients, but with opposite signs. So I think what I'm going to do is multiply the first equation by -2. All right, so I'm going to say times a -2 across every item, every component. Okay? So if we distribute a -2, we're going to get what? -6 plus 2y equals -16. This looks like another one of those, right? And then we get 6x minus 2y equals 10. And I think we had that same thing that we had just a moment ago. On the left, everything cancels, all right? A number plus its opposite. So on the left, we have 0. On the right, we have 4. This is a false statement, right? So then this is our symbol for like no solution, or the empty sign. So these are the image of this would be 2 parallel lines with different wire intercepts. So we got no solution here. Nobody like to give us that one so much, but that's okay. Let's generate. Go to question 44. I feel like it's actually being random today. Sometimes it's saying, like I know one day it just stayed in the 60s like all day. The whole point is I needed to jump around. Okay, I use transformations to graph. Okay. Can I just, are you gonna please behave? We'll just work with that. Okay. So the parent function here is absolute value of x, right? So without any manipulation, it's just a v where the vertex is at the origin. Notice we added a positive number on the inside, right? So that means there should be a horizontal change and the reverse of our intuition. Positive 2 is to the right, but again, we have to use the reverse of our intuition. So this should be a v that moved left by 2. The only v that moved left by 2, hopefully you're thinking b. I would do the polls, but we're short on time, so that's why I'm just doing these, because I'm trying to get as many in, and I know we don't have a lot of time. Also, there may be an extra credit opportunity in the form of your overall My Math Lab score. Um, I think it's this one. So if you've done everything and you just need something more to do and you want to try to get more points, you maximize your overall MyMathLab score. Again, if I can, I'll take your overall MyMathLab score, scale it to 10% of your overall grade, and add it as a bonus. As long as it doesn't skew the grades too much, you potentially could earn up to 110% out of 100. I think also with this group, hopefully everybody has been in high communicado with my colleague Dr. Lamar for the lab. So we're pretty much at the end now, but just follow her instructions. She's going to give me a grade for each of you that I'm going to scale so that her portion is 10%. So like what we do together is 90%, her portion is 10%, and then there's a potential bonus for an additional 10%. It just depends on how it goes. Okay. All right. So this question 41 comes to section 1.5. We're asked to describe the transformations that produce of the graphs of G and H from F. Okay. So the parent function here is the square root function, right? So you should have an image in your mind. The best way I visualize or remember the shape of the square root function, to me, it looks like it's the top half of a sideways parabola. So if you think of a U-shaped curve, you turn it to the right, cut it in half horizontally, and you only keep the top half. That's the square root function. Okay. Okay. So for A, notice that +5 is outside of our basic function, right? It's outside the radical. So outside manipulations tend to cause a vertical change. It should go up 5 units. All right, so we're just going to go with B here. Okay. And then for the second part, we subtracted 3 on the outside, so it should be the reverse, 3 units down. Okay. Not too bad. Let's generate 32. I wonder if I can just have it automatically keep generating. Let's go to question 32. Right here. Write a linear function that has the indicated values and sketch the graph. Okay, I was trying to think if I can do this without taking notes, but the simple thing seems to be to just take some notes. Write it out. Don't be lazy. Like, lazy is such an interesting word because that's just a negative connotation. Like in one connotation, it means like, sloth or whatever. But then in another context, it means efficient. Like, what's the difference between laziness and being efficient? It's like they're similar in connotation. It's just one is positive and one is negative. You know what I mean? And a lazy, efficient doesn't necessarily mean lazy, but again, they're similar. So it's like a lot. Oftentimes, when I'm saying lazy in my mind, I'm really thinking efficient. I was like, they're not lazy; they're just efficient. I can't be mad at them because they took the time to figure out how to streamline whatever it is that they're doing. Right? Mind your own business. So just mind your own business. These are the conversations I'll be having in my head. Going everywhere. Okay. So we have these 2 order pairs. Let's go ahead and just kind of capture these order pairs. So we have -1, 2, and then we have 3, 14. Okay. So now, I'm a fan. Whenever I get order pairs, I like to just label them x1, y1, x2, y2, 2, right? And then also here, since we're working with lines, whenever I'm working with lines, hopefully you have a formula sheet, a sheet where you've collected formula throughout the semester. Every time you get a formula, you add it to your formula sheet. Whenever I'm working with lines, I like to have these 3 ready to go, right? Let me see. So the first one is the slope formula, y2 minus y1 over, let me make that a little bit cleaner, x2 minus x1. Again, this is our slope formula. I don't know what symbol I'm drawing. Good enough. I feel like I should label it just for some context. So this is our slope formula. Okay. Then we have point slope. I tend not to use this one, but I still have it ready to go. Point slope formula. That's going to be our y minus y1 equals m times x minus x1. And I know we talked about a way to convert the slope formula into the point slope formula, right? It's a simple algebraic operation. And then the last one is a slope intercept. Slope intercept formula. Right. I know the spelling's off, but I'm just trying to get the gist across. This is going to be our y equals mx plus b. Right. So whenever I'm working with lines, I generally like to have those three formulas ready to go in some capacity. So here it looks like a good place to start is our slope formula. So again, slope y2 minus y1 over x2 minus x1. So our y2, so I'm going to say y2 minus y1 over x2 minus x1. Our y2 is 14, our y1 is 2, our x2 is 3, and our x1 is -1. Another random thing, I'm always like on YouTube, and this morning before class, this string of videos popped up where they had the Black Power Ranger and Tommy. That's the best. I can't think of their names. I can't think of his name, but that's how I remember. But they were basically reviewing like morphing from like other cast members, and then come to find out, I never knew that the Black Ranger was missing a finger. I was like, what? So like when he was like, I was like, dang, I didn't know he was missing a finger this whole time. So I thought that was, again, hence random stuff. Okay. So anyway, so just go back and check and see if we can see his missing finger. I don't know if it's going to show through the gloves. Well, now another thing about Power Rangers, every time they morphed and they were in the suits and Rita and all that stuff, none of that was done by like American actors. That they basically took all those scenes from like some foreign show, and they just weaved in the whole the narrative that we're familiar with the actors and all the other stuff. But those fight scenes were like a whole nother show. So it might not show when he transforms. Anywho, just random, childhood is never what you think it was, right? So double negative is a positive. That's a 4. 16 over 4. Here, we'll write it. 16 over 4 reduces down. Oh, it's what, 4, right? Nope. Back up. That's not right. That's a 12 over 4, right? Which is 3. So it looks like the slope is 3. Okay. Now I'm a fan. If that's our slope, I just one of my students showed this to me, and I've just been using it ever since. Well, I just like to go straight to y equals mx plus b. We could use point slope, but I feel like this is more simple. So let's plug in what we have. We just got the slope of 3. We're going to choose a point. I'll choose the first one because the numbers are smaller. We don't know our y-intercept just yet, and our corresponding y is 2. So add 3 to both sides. It's like we get a y-intercept of 5. So then ultimately, we get y equals 3x plus 5. Okay. Y equals 3x plus 5. Speaking of 5, we got about 5 minutes left. 3x plus 5. And we're going to check before we submit. We got 3x plus 5. So let's see, when x is -1, -3 plus 5 is indeed 2. When x is 3, 9 plus 5 is indeed 14. Let's go ahead and submit this. Okay, let's try to get some more in there. Oh, wait, we're not done. So y-intercept was 5. It had a positive slope. So it can't be b or d because they both have negative slopes. And a looks like it has the wrong y-intercept. So by process of elimination, I'm going to go with c. Also, with the final, I want to say get unlimited attempts, right? And the system is set to take your highest score, right? So that's huge. You can, if you go ahead and get started early, you finish it. If you don't like the score, you get as many attempts as you want for those 5 days, right? Okay, let's generate. We can go to question 16. Right there. Rewrite the given equation in slope-intercept form. So that's like y equals mx plus b. So in other words, just solve for y. Okay. So y equals -3x plus 2. So The wire, I'm just going to click in two random spots. Plus 2, so we had a wire intercept of 2, so 0, 2. And then a slope of -3. So we go what? Down 3 and over 1. That puts us like here. If we go down 3 and over 1, that gets us to the second point. Okay, I'm going to hit save and check. Full 3 minutes, let's generate. Let's go to question 82. Okay, so we'll do 83 since we've already done 82. Synthetic division, define the quotient and the remainder. Sure, why not? This one has placeholders. You see that? This one is a little bit more interesting than the previous. This will probably be our last one for the day. Okay. Okay. So if we're going to do synthetic division, potential 0 goes in our chair, which is going to be what? -2 from the denominator. Okay. We do need placeholders, right? So power of 6 is there, so we'll do that one. Power of 5 is missing, so we need a placeholder there. Power of 4, power of 3, power of 2 is missing. Looks like power of 1 is also missing, and then 4, right? So one way to know that you got all the placeholders, whatever the degree of our polynomial is, we need the degree plus 1 number of coefficients, right? So since it's a degree 6 polynomial, we need a total of 7 coefficients, right? 1, 2, 3, 4, 5, 6, 7, right? So we're good there. Okay. First one just comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add. 52. It's getting up there. 104. 108. And again, we started with a degree 6, so at this point we're at a degree 5. Let's just go ahead and submit this. This is our last one. Do not factor the quotient. So degree 5. X to the power 5 minus 2x to the power of 4 plus 6x to the power of 3 minus 13x squared plus 26x minus 52. They might want the remainder. I'm just going to go with this for now. Okay. And then the remainder, what does it say? 108. All right, gentlemen, are there any burning questions before we go our separate ways? So I'll make a copy of these notes available at the end of the day because I think I'm just going to tack on with my other groups to this one set of notes and just load one notes for the day. If there aren't any burning questions, let me see. So again, on Wednesday, I want to take some time to like update grades and just I want to do a check-in with everybody, and then whatever time we have left, we'll do some review if we have time left. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening and good luck with everything. You know how to reach me if you need help. All right, guys, good luck with everything. Take care. See you Wednesday, same time, same place. Peace. Yeah, the Power Rangers might be Japanese. Like, yeah, I think so. I just didn't. I didn't want to, you know, call it say Japanese, and they weren't Japanese. Like, I didn't want to say that. Let me see. Can we do it? Yeah, we did all that. Okay, yeah. But yeah, just interesting random stuff, right? All right, guys. Good luck. Take care.